I'm not going to be there tomorrow because today it's already 12:30 in the night. Something else that just came up that I need to take care of tomorrow. So I decided, why don't I like record the class for tomorrow? Today, why don't I record the class for today so you guys can have a lesson and you're not missing out anything. Let's start with what we've already done. So we did electron configuration, which is arranging the electrons in the s,p,d,f orbitals. We broke down the periodic table into different types of metals. All of these are metals, metalloids, metals, all of those are metals, and then from here on out they were non-metals. And we looked at how to do, just to refresh, just in case someone doesn't remember, let's look at how we did electron configuration. If I had to do Na, I would start from here, 1 1, this is S, these two columns are S, so I would go 1s 1 and 2, so 1s2, and then I come down here, energy level 2, s orbitals, 2 still in the s, 2s2, and then I'm still in the second energy level, which means I'm in 2p. I count all the way down to neon, which is 6, 2p6, and then I come up to sodium. Sodium is an energy level 3, still orbital s, first electron. Now, when we were talking about electrons, we also talked about the fact that electrons are always going to want to stay at a lower energy level. So in order to stay at a lower energy level, they're going to want a full orbital. So if I look at this that I have done here, the full energy level would be up to this, right? So neon. So they're going to want to stay as stable as the noble gases, which is in neon. One of the ways sodium can achieve this is by actually losing one electron. So if it were to lose this electron, it would have 11 protons and 10 electrons, making it positively charged. Right? So so like I said, sodium is going to make is neon. The short form of it would be neon. I put the parentheses around this, and then that would be 3s1. If I was to draw the boxes, there be one box here, and there's one electron here. So because it's one electron, it can actually go ahead and lose this electron. If it loses this electron, then it becomes Na+. So it would really help if you can just make a little kind of legend that says loss of electrons. Loss would lead to a positive charge, right? It's positive charge because there are more protons than there are electrons. And so similarly, let's take chlorine. If I take chlorine, which is 17, the closest noble gas to this is also still neon, right? I would go neon, which is 10, and it would then be 3s1, and 3p5. Neon can, for neon to look like a noble gas, to be exactly like a noble gas, it would have to go from neon to the next closest gas to it, right here, there is the noble gas that is here is argon. Please pay attention to your periodic table, otherwise none of this is going to make any sense. So to go to argon, it would have to add 1 electron. So for me to add an electron, here I would have 17 protons and 18 electrons, giving it a negative charge, right? So that would mean gain of electrons, gain would be negatively charged. Okay. So you know it sounds counterintuitive. So it's like if you subtract, you get a positive charge here, and if you add, you get a negative charge. Positive ions are called cations. They're called cation. And negative ions are called anions. Okay. So this is what we did so far. Now, if an electron is lost or an electron is gained, if something is losing an electron, something has to gain an electron, because the universe basically runs on one principle, and that principle is the law of conservation of mass. What does law of conservation? You should have learned this in the beginning of the year. If you have not, I'm just going to go over it again. Cations are positively charged electrons, which means they're losing an electron, and anions are gaining an electron. The basic law that governs the universe that you guys would have learned in the beginning of this year is the law of conservation of mass, which is mass can neither be created nor destroyed. It can only be transformed or transferred. So if something in the atomic universe is losing an electron, there should be something else that accepts it. So if you have a negative charge and a positive charge, like we talked in the previous classes, unlike charges, something that's negative and something that's positive tend to attract each other. So they're going to form what is called as a bond. The first type of bond is an ionic bond. Let me just write that down. The first type of bond is an ionic bond. So just like the name suggests, it is made up of ions. A positive ion and a negative ion. A positive ion is called a cation, and a negative ion is an anion. So when you have something positive and you have something negative, and they kind of are attracted to each other. So if I had, let's say I have a sodium ion. The sodium ion is formed by losing 1 electron, and a chlorine ion is formed by gaining 1 electron. So they're basically going to arrange themselves in the form of a lattice structure. Let me write that spelling down. So if I have sodium, which is positively charged, I would have right next to it would be a chlorine. This is positive, this is negative, and then right next to that would be another sodium. Right next to that, another chlorine. And right here would be another chlorine, sodium. So positive, negative, they kind of alternate themselves and they look like almost like a basket structure. So it's going to look, oops. It's going to look something like that. Like a lattice, like, you know, like a basket weaving structure. So it's going to, if you've seen lattice structures in gardens and stuff like that, that's basically what it's going to look like. And that's an ionic bond. How do we name these ionic bonds? We keep the positive ion as is. So sodium, you just call it sodium. Chlorine, the last syllable, you drop that and you do IDE. So it's sodium chloride. Okay. So let's take some definitions down for this, and then please ask Miss Allen to like pause wherever you need it to be paused so you can write stuff down. So like we stated before, an ionic bond exists between a non-metal and a metal. Non-metals are from on your periodic table after carbon. So oxygen, nitrogen, fluorine, that the things, all the electrons that are in that column, all the atoms that are in that column would be a non-metal. So by looking at your periodic table, you should know by now that non-metals make a negative charge, which means they gain an electron. And metals are everything till carbon. So under metals, you have alkaline. On your periodic table, you should have written down the groups. Column 1A is alkali metals. Column 2A is alkali earth metals. And then the whole B column is transition metals, and so on and so forth. And then you have the little box that we filled in, and those are called metalloids. For ionic bond purposes, we're going to treat metalloids exactly like a metal. So all metals are going to gain electrons and they form a positive charge. So non-metals are going to form negative charges because they gain electrons. They're called anions. And metals are going to lose electrons, hence they are called cations. So just to recap, why do things form ions? The reason they form ions is because they can be like noble gases. Noble gases are the ones in column 8A. They have 8 electrons in their outermost orbital. The outermost orbital is also called its valence shells, right? So in order to fill the outermost orbital, if I break the periodic table down, I have 2 electrons in the s orbital and 6 electrons in the p orbital. So the valence shell for everything on your periodic table except for hydrogen, helium, lithium, beryllium, boron, except for those things, everything else is going to strive to make an 8. These guys here are going to try to make a 2 because hydrogen is trying to, well, lose an electron and become a proton. So we'll get to that later. Lithium is going to lose 1 electron and become like helium. Beryllium is going to lose 2 electrons and become like helium. And this guy is boron is going to lose 3 electrons and become like helium. So except for these 4 guys, this one is actually an exception to a rule because they don't gain. Hydrogen does not gain an electron. Instead, it loses an electron and becomes a proton. So we'll get to that later. All of this they do is so that they are more stable and they are at a lower energy level. The way it's going to fill its valence shells is by losing or gaining electron. And valence shells are always only S and P. So if you remember when we did iron, when we did Fe, the highest energy level was, so we're going to go Ar and then 4s2 and 3p6, right? The highest energy level is still 4s. I mean, sorry, not 3p, my bad. 3d6. It's 3d6. So the highest energy level is still 4s2. So the electrons that they're going to lose is in this column, in the 4s2 column. It's not from the 3d. So the type of ion it's going to make is Fe plus, oops, it's going to make Fe plus 2. It's going to make an Fe plus 2. The reason it makes a plus 2 is because the highest energy level where it has an electron is in 4s2, not 3d6. Now, Jack, we talked about how Fe can make plus 3 also based on Hund's rule. If you don't remember Hund's rule, look up in your notes. Electrons will prefer an half full rather than a full. I'm not going to expect everybody else to be able to make compounds with that, but Jack, I'm going to expect you to do it. So this one says an atom will bond with as many atoms as it can to take its outer shell. This is what we were talking about in the couple of minutes ago when we said there is law of conservation of mass. So if something is losing an electron, something else has to gain an electron. Electrons are negatively charged, and you cannot actually have electrons just freely moving electrons. They become free radicals and they start attacking every other element, and it's really, really very dangerous. So electrons have always got to be within the confines of an atom, either in the form of an ion or in the form of a covalent ionic bond and then covalent bond. We'll get to that in a second. If by any chance you forget, I don't know how these electrons are formed, this number here kind of also tells you what type of ions they're going to form. So please take out your periodic table and write this down on your periodic table. This is going to, everything in this column is going to form a +1. Everything in this column is going to form a +2. Everything from here to here is going to form more than one ion. These guys are going to form more than one ion. More than one ion. However, the first ion that it is going to form is a +2, just like we did in when we did Fe. The highest energy level is going to be 4s2, so it's going to lose the first 2 electrons from s. Hence, the first ion that it forms is a +2, and that is common for every single one of these atoms. This one is going to form a +3. This is 0. That means it's not going to form an ion at all. Anything in this column, in the fourth, in 14 or 4, is not going to form an ion at all. This one has 5 valence electrons, 15, which is 5, has 5 valence electrons. It needs to go to 8, which means it gains 1, 2, 3 electrons. This is going to form a -3. This is going to form a -2. This is -1. and this is 0. So if I want to form a ionic bond, I have to combine two ions. So I would combine the plus, everything in this area, which is this column, these columns, this column, anything here, I combine with anything here. So if you want to figure out if something is a covalent bond or an ionic bond after we've done covalent bond, you can in your head like create a, think of this as being, like this being an imaginary line where it's 4. Let me erase this. Think of this as being an imaginary line. An ionic bond is when you cross that imaginary line, right? If you cross that imaginary line to make a bond, then it is an ionic bond. So far, so good? It is an ionic bond, has certain properties. They all exhibit certain universal properties. The first thing is a high melting point. So a melting point is, a high melting point. Melting point. What does the word melting mean? When you melt something, it's essentially going from solid to liquid, right? It's going from solid to liquid. The only way you can go from solid to liquid is if you increase the temperature. If you want to change ice into water, you have to increase its temperature. As everybody knows, water freezes. Freezing point would be where you go from in this direction. This direction is freezing point, liquid to solid. So water freezes at water freezes at 0 degrees Celsius and it melts. That means it goes from solid to liquid at 0 degrees Celsius. I'm sure you guys have learned this in like third grade, fourth grade, fifth grade, some grade. If you take salt, common salt, and you try to melt it, it requires so something like water, which is not an ionic bond. It's going to melt at 0 degrees Celsius. And if you guys know the conversion, it is 32 degrees Fahrenheit, right? At 32 degrees Fahrenheit, water will melt. Ice will become liquid. If you try to do the same thing with salt, which is common household salt, you need this to be about 801 degrees Celsius, or about 800 degrees Celsius, or 1400 degrees Fahrenheit. Around 1400 degrees Fahrenheit. So that's what we mean by something having a high melting point. Because the two components of that is a positive charge and a negative charge, they are very much attracted towards each other. So they don't melt that easily because the movement between them is much lower. They're a good conductor of electricity. The word conductor meaning it allows electricity to pass from point A to point B. If you know anything about electricity is just electrons moving from point A to point B. And if you have a positive charge, a negative charge, a positive charge, a negative charge, it's very easy for electrons to move through them. Hence, something that is salt moves electricity very well. This is one of the reasons why if somebody's is having an electrical shock, you try not to keep any kind of water in around them, because water has a lot of dissolved salts in them. They're almost always a solid at room temperature. They're not always a solid at room temperature. There are some salts that are not solids at room temperature, but a majority of them are solids at room temperature. So just to recap, we talked about cations, we talked about anions, we talked about how cations are made by metals, anions are made by nonmetals, and if you combine cations and anions, you will get something called as an ionic bond. Ionic bonds have a very high melting point. They tend to conduct electricity. They are solid at room temperature. How do I know? By looking at the periodic table if something is going to form an ionic bond or a covalent bond. If you draw an imaginary line right by where carbon is, any bond that is formed between two elements by crossing that imaginary line is going to be an ionic bond. So tomorrow in class, we will learn how to make ionic bonds. So we learned how to make ions. Now we just have to learn how to put them together and name them. Okay, see you guys tomorrow. Bye.